Okay, let's look at the first theorem. Consider a memoryless source xi. Let Cn be the set of all the optimum codecs, optimum one look-ahead codecs that achieve the minimum total distortion. And the claim is there exists a code in Cn that satisfies the following structure. For every two source sequences Rn and Sn that the last symbol is the same and encoded sequence up to time n minus 1 is the same, then the encoded sequence is going to be the same going forward. In other words, future encoders do not depend on the specific choice of Rn or Sn, or is independent of Rn or the actual source sequence. It's a function of encoded sequence and the last symbol, last source symbol in the sequence. Now, let's look at the proof of that. Let's pick a codec in Cn. This is an optimum code. We define a non-conforming pair Rn and Sn to be a pair of source sequences that satisfy these two conditions. They have the same last symbol and they are mapped to the same n-1 encoded sequence, but they do not satisfy, but they have different encoders going forward. I pick Rn and Sn let A be the set of all non-conforming pairs, and I pick one pair out of A. If A is not empty, I pick a pair from A that has the shortest length. There might be multiple of them with shortest length, but I pick one of them. Now, consider Vn-1 to be the encoded sequence for these sequences Rn and Sn. And I define V to be the set of all source sequences that are mapped to Vn-1, and they share the last symbol with Rn. Obviously, Sn is one of the elements of the V. Now, I can break down the total distortion between those sequences that have an element of Xn as their first n symbols, and those sequences that do not have an element of a V as their first sequence. So for the ones that do not have an element of V as their first n element, we don't care about them. But for the ones that have Xn as an element of V, I can break down the terms because the source is memoryless. I can break down the probabilities, and then for the second term, for every element, for every Xn in V, I can break down the distortion into three parts. The first part is the distortion that has occurred for the first n-1 element. The second term is the distortion of the nth element, and then the last term is the distortion of the elements going forward. This term is all the distortion that has occurred so far, and I cannot do anything about it. But our claim is summation of these two terms should be independent of choice of Xn. Otherwise, we can improve the encoder. So the summation of these two terms should be independent of Xn. Otherwise, we pick the one we pick Xn in V that minimizes the summation and use that code for everyone. Because this term should be the same for all Xn's in V, then it means that I can reconstruct a new code. I call it F bar and GI, F bar I and GI, that basically I pick the encoder of Rn and apply it for all elements of V. But for any source sequence that the first n element is not in V, or the source sequences before the first n element, I just keep the original encoder. So this new encoder has the same distortion as the original encoder, so it should be optimum. Plus, the set of non-conforming the set of non-conforming sequences for the new encoder is strictly smaller than the set of non-conforming pairs for the original encoder, original codec. Hence, there should be a code in Cn that the set of non-conforming pairs is empty. Otherwise, we can improve upon that. And the one with the empty set of non-conforming means it satisfies our, it has the structure that we had in mind.